Hey guys, welcome to Simply Electrical. We're going to go over some range calculations in this video, but this is going to be mostly just examples. I'm not going to get into a lot of detail on how to do the calculations. I do that in another video, a deep dive video that I made, and it goes into every detail and gives you all the information you need. It shows you where to get the information in the code book and so forth for every calculation. This one is just going to be mainly going through at a crash course pace, so we're going to go through quickly. But we're going to get through a bunch of examples, so you guys can just come here, check through the examples, make sure you're doing them right, see the shortcuts, the ways to do them that make it much easier. I have some formulas and tables that I've developed that really help out. Now this is on the 2023 code, but it also is for any code cycle before that as well, any of them that are in use today across the nation, because they haven't changed Article 220.55 really at all, much at all. There are a few changes, but those are just in the notes to the table, and it only affects branch circuits, not load calcs. Okay, here's the text. I'm not going to read this, but it's here so you can reference it. If you need to, you can pause it or whatever. I'm just going to press right on because, again, this is a crash course. You can see the delta symbol over here. That tells us that there was a change made. Again, that was only to the notes and only to ranged branch circuits, not load calcs. One thing I want to mention, I am going to be using the word range as a general term for all the cooking appliances, and that's generally what we do in the trade. When we say range chart or range table, we mean the table that covers all the cooking equipment. But there are situations where I will mean specifically ranges only, and when we get to those points, I will let you know that, because some of the things don't apply to all appliances and only apply to ranges. So we'll talk about that when we get there. Okay, now this is the table, 220.55. This is the range table. This is the one you go to calculate your ranges, whether you have one range or a whole bunch of ranges like in a multifamily. This is the table you go to. So just a real quick word on how it's laid out. You got the three columns, A, B, and C. It tells us that C is to be used in every case unless note 3 allows you to use A and B, which it's just all determined by what size your range is. You can use C though in all cases. Anything under 12 kW, you can use column C. Now you're not going to want to do that, especially on an exam, because on an exam you're trying to find the lowest kW rating for a range. So that's usually going to fall in column B or A if indeed your range size falls in these parameters. So just to let you know, you can use C for anything, like in the real world. If you're just doing a quick calculation and you just want to go to C real quick to find out what your demand factor is, you can use that. In fact, you're supposed to use it unless you want to use note 3. Okay, now here are the notes that are at the bottom of the table in the code book. Again, I'm not going to read through these, but I have it here just for your reference. We're only going to be going over notes 1, 2, and 3 that affect load calcs. 1 and 2 are a little bit confusing, so I made up some formulas for them. Here they are here. Note 1 formula is right there. Note 2 formula, basically you're just averaging the ranges with a special condition, and then you're using the same formula again after you average. Okay, now here is a formula table that I've constructed, and this makes it so simple. You will only need this table and table 220.55 just to reference, and you can do any range calc that comes at you. This makes it so simple because all you have to do is figure out what size range you have. That tells you immediately what column you start with, and once you're in that column, you stay in that column and you get your answer, and it's really simple. These get a little more complex over here, as you can see, but even those are pretty simple. Once you just have this formula, you just plug your data in and you go. I'm going to quickly go over how this works, and we'll start working through it with our example problems. First, let's see this note at the bottom down here. It says ranges at or under 1 3/4 kW and over 27 kW cannot be applied to table 220.55 and must be calculated at nameplate value. So that's very important. Anything over 27 kW or under 1 3/4 kW does not get a demand factor applied to it ever. They get taken at full nameplate value. That's for ranges. Now, other cooking equipment at or under 1 3/4 kW and over 12 kW must be treated likewise. So again, anything over 12 kW for like an oven or a cooktop, you got to take it at nameplate. Okay, I just wanted to make sure that's clear because that's important to know. The other thing is there is a difference between cooking appliances and ranges. So here in these three columns in this table, this is all cooking appliances, including ranges, but then these two only apply to ranges. And so we'll talk about that as we go along and show when to include all cooking appliances. So with this table, you can see you've got the different categories here for sizes of range, and then it tells you what note applies. And then you're just going to go down. You're usually going to start with your number of appliances. That's almost always the first step, is you start with a number of appliances, and then you apply your demand factor, and you get your total demand. And that's how you do the first column, second column, and third column, except in this column you don't have to apply a demand factor because it gives you your kW demand in column C. And then in this column over here, for over 12 kW through 27 kW of equal ratings, you do the same thing. You get a value C, and then you got to plug it into that formula that we just saw on the previous slide, and then you get your total demand. And then you have a couple more steps here for over 8 3/4 kW through 27 kW of unequal ratings, note 2. You do the same steps, only here you got to take an average, and then you punch that into your formula, and you come up with your total demand. Now, as we go over these, I've got 8 different examples, and it should cover every major scenario type that might hit you. I know nothing is worse than getting an example of every scenario except the very one that applies to your situation. So hopefully I didn't miss any. Okay, our first example, we're going to start small, and we're going to go over the first 2 columns. So I have this little section of that table, and I've just cropped it down so that I can fit it on the page. So we're going to take the first column here. We're going to take a 3 kW range, and that fits in this first column between 1 3/4 and 3.5 kW. And it's note 3 applies to that, and it's written down here, note 3. Again, I won't read it, but it's there for your reference. It just says that if your range value falls within column A or column B of table 220.55, you can use these columns and the values, the percentages they give you for demand. So what we're going to do is we're going to take a 3 kW range in column A, and we're going to do 1 range, we're going to calculate 4 ranges, and then we're going to calculate 50 ranges, and we're going to do that each time so we can see the differences and how to apply different numbers. So the first one, we have 1 range, and so our note says the number of appliances times the nameplate value. So 1 range at 3 kW, which is nameplate value, that equals 3 kW. Then it says go to column A and take the percent value on table 220.55. Table 220.55 for 1 range, column A says 80%. So we take 3 times 80%, and it gives us 2.4 kW. And that's our answer. That is our demand. So it's as easy as that. Next one, we have 4 3 kW ranges. We take 4 times 3 kW equals 12 kW. We have 4 ranges. We go down to the table, 4 ranges, 66%. So we go 12 times 66% equals 7.92 kW, and that is your answer. Next one, we have 50 ranges. So this is a bigger multifamily dwelling. We go 50 times 3 kW, we get 150 kW. We go down to the table. I don't show it on here, but if you went down to 50, column A would show 30%. And so we do 150 at 30%, and it gives us 45 kW. And that's your answer. Now, real quick, I just want to point out, remember when I said you can use column C if you want to? Well, let's see how that would have fared here. So if we use column C for the first one with 1 3 kW range, we got 2.4 kW. Well, column C gives us 8 kW, so it's way bigger. So it's much to our advantage to use column A instead of column C. With 4, we got 7.92 kW, and it would have given us 17 kW for 4 ranges in column C. So again, it's way different. It's rare, but sometimes column C is actually not bigger than column B, which we haven't talked about yet. But it's always bigger than column A. I'm almost positive of that. And speaking of column B, we're going to go over that next. We have a 7 kW range, and that falls into column B, which is between 3.5 through 8 3/4 kW. Again, note 3 applies. And we've got 1 range at 7 kW. Again, we're just going to take the number of appliances times the nameplate value. So 1 times 7 equals 7 kW. Then we're going to go to column B and take a percent value. And I'm not going to keep flashing the table up here. You'll just have to take my word for it. These numbers, you can check it yourself in your code book or refer back earlier in the video to the table. So column B gives us 80% as a demand factor. So 7 times 80% is 5.6 kW. If we have 4 ranges, 4 times 7 is 28 kW. 28 times 50%, which we find in column B for 4 ranges, and that gives us 14 kW. 50 ranges, 50 times 7 is 350 kW. 350 times 24% for 50 ranges gives us 84 kW. So you can see how substantial that difference is. 350 kW if we went off nameplate, and it drops all the way to 84 kW, 24%, less than a quarter of the nameplate rating. We're allowed to do this just because it's on a feeder, so we're getting our bulk discount for bundling on a feeder. Okay, and that's easy. That's how column B works. Same way as column A. Very simple. Okay, now the second sentence down here in note 3 tells you that if you have ranges that fall in both columns, let's say you have several ranges and they're of different values and some fall in column A, some in column B, what do you do then? Well, it's really just as simple, just one extra step. So here we have a 2 kW, 3 kW, 5, 6, and a 7 kW range, all on one feeder. So all we do is we take the ones that fall in column A and use column A to work them out and calculate those, and then we take the ones that are on column B and do the same thing with column B, and then we just add them together. So we have a 2 and a 3 kW, which falls into column A. So we just calculate that out. We use a column A value of 75% for 2, because that's just 2 ranges. So we go down to the 2 line in the table 220.55, and we do 10 kW times 75%, and we get 7.5 kW. Then we go to column B. We have 3 of those, 5, 6, and 7. They all fall in column B. 3 times 18 kW, because that's what we do. You got to add them together. 5, 6, and 7 is 18. 3 times 18 equals 54 kW. 54 kW times 55% is 29.7 kW. And then the last thing we need to do is just add these two values together, and we get 37.2 kW. And that's your total demand load. Okay, so we're done with columns A and B. Now let's go on to column C. So now we have a 9 kW range. We just go to column C and we get 8 kW right here. One range, 8 kW. It's that simple. This is the easiest. Anything from 9 to 12 kW are the easiest ranges to calculate, because you just go down to the number of ranges you have, you just go over, and that gives you the kW value right there. So we have 4, 9 kW, so 4, 17. It doesn't even matter exactly what your kW range is, as long as they're all the same and it's between 8 3/4 and 12. It's always going to be the same number. So 17 kW for 4 ranges that are 9 kW nameplate. Okay, then we go to 50. Now there's one extra step. If you get above a certain number, and you can see this in your code book when you see the full, or you can go back earlier in this video and see the full table 220.55, and you can see how the last two sections are a little bit differently. They have a little equation down here you got to factor in. And that's why I chose 50, because it puts us into this place where you need to do the extra step. So what you do, the same thing, you go down to 50 appliances, then you go across, and it says, okay, 25 kW plus 3/4 kW for each range. So you have to go 25 plus 75% times the number of ranges, 50. So you go 50 times 75% plus 25 equals 62.5 kW. And that is your total demand. So this is the table over here. Again, I forgot to mention that. And this just tells you what your steps are. Apply the number of appliances to column C, you get your total demand. It's that simple. Okay, now we have a 15 kW range. Okay, now down here I have note 1, which covers anything over 12 kW through 27 kW ranges. Now this is ranges only. This does not apply to cooking equipment. Everything else we've talked about so far applies to cooking equipment, including ranges, but this is just ranges now. And anything over 12 kW through 27 kW will fall under column C, but it has some special provisions also. And this is where that one formula comes in, which I have written right here. So going through the steps. Now these ranges have to be equal rated, just like it says in the note down here, all of the same rating. You apply the number of ranges to column C, just like before, and that gives you your C value. And then you're going to apply the range KW, which is 15, and the C value you just got to this formula. Those are the two variables here. And then you're going to get your total demand. So let's do that. We have one range, 15 kW. We go to column C. Column C says 8. So 8 kW is our C value. Now if we had 4 15 kW ranges, we go down to 4, and 17 is our kW rating. Go down to 50, and again we do the math here, and we get 62.5 kW, just like before. However, we're not done. Then, once we have that, we've got to apply these values, the C value and the kW of the range, to the formula, this formula here. So we do that, we take the 8, the C value, plug it in here, 8 plus 8, then we take the kW for the range, 15 minus 12 times 0.05. Compute that out, and you get 9.2 kW, and that's your demand rating for the range. 4 ranges, same deal, get your demand value, plug it into the formula, 17 and 15, and you get 19.55 kW. Again, same thing, 50 ranges. Get your C value, plug in the numbers, you get 71.875 kW. And remember, these are of equal ratings, so it's note 1 that we're using. Okay, now we have unequal rated ranges over 8 3/4 kW through 27 kW. Okay, so we're going to have a bunch of these. We're going to have 4 ranges. We have a 13, 15, 20, and 25 kW range. I've got note 2 written down here, so you can read that. Still we're in column C, and we're just going to take 4 ranges here because that's what we have. So over here with our rules, we have apply the number of ranges to column C. Okay, we have 4, so we go to column C for 4. If we remember, that gives us 17 kW. Yep, so our C value is 17 kW. Then we have to average all the individual range values, and any range values under 12 kW equal 12 kW. Well, we don't have any of those in this problem, so we don't have to worry about that part. So we just average all the individual range values, and we come up with a new range kW value. So we average these out, 13 plus 15 plus 20 plus 25, that equals 73, divided by 4, divided by the number of ranges, and you get your average of 18.25 kW. Once we have that value, then we can plug it into our formula here. We got 17 plus 17 times 18.5 minus 12 times 0.05. We get 22.313 kW, and that is our total demand. Okay, now let's try another one of unequal rating, only this time it's going to be a little different. So now we have a 9, an 11, a 22, and a 26 kW range. We still have 4 ranges. We use column C. It tells us apply the ranges to column C, just like we did. Give it a value of C from column C. That gives us 17 kW, just like before. And then it says average all the individual range values. And now this time we do have some that are under 12 kW. So anything that's under 12, this 9 and this 11, we have to bring those up to 12. So now we have 12 plus 22 plus 26, and that equals 72. Then we divide by the number of ranges, so divide by 4, and we get 18 kW. Now that we have that, we can plug it into our formula again, and we get 17 plus 17 times 18 minus 12 times 0.05, and we get 22.1 kW, and that is our total demand. Okay, so that does it for single phase ranges on a single phase service. Now, if you have single phase ranges on a 3-phase service, there's something special you've got to do. And this is very important because most of the larger multifamily dwelling buildings out there are going to be 3-phase. They're going to be 120, 208 3-phase most likely. And so you are going to be dealing with this in real life and on tests. So this is something you really need to know. It's not very complicated at all once you have the formula, and I've made up this formula here, so it's very, very simple. Basically, all you're doing is you're adding a couple of steps, and then you're doing your calculations just like we talked about, just like normal, and then you're adding one more step and you get your final total. And we're just going to do one example for this because they're all the same except for you just add these 2 steps before and 1 step after your normal calculations. Okay, so here's an example. We have 15 kW ranges. We've already done this example, but we're going to come up with a different answer this time because we're dealing with 3-phase. Basically what we're doing is creating an imaginary single-phase scenario, finding our demand, and then converting back to 3-phase again. Now you can check out my deep dive video for a thorough explanation of how that works, but for here we're just going to shoot through this. 15 kW ranges, 3-phase service. We have 50 of them. This tells us to take the number of ranges and divide by 3. We get 15.7. It tells us to round up the answer and then multiply by 2. 15.7 rounded up to 16. 16 times 2 equals 32. And that's our new number of ranges, 32. Then we just do the calculation like normal that we would have done if it was single phase, because that's what we've done. We've taken this 3-phase, turned it into single phase, then we can do our calculation, and then we convert it back to get our actual number. So what we do is we take 32 ranges, because that's our new number, and we apply it to here. So we have 15 kW ranges, we have 32, plug that into column C. Okay, so remember when you go down on the chart, there's a special formula you got to do, little equation. So if you have 32, you have to add 15 plus whatever number of ranges you have. So 32 plus 15, you get 47 kW. That's your C value. Plug it into your formula. You get 47 plus 47 times 15 minus 12 times 0.05. That gives you 54.05 kW as your demand. All we have to do is plug that number right into this place over here, and then it tells us take our demand times 1.5, because 1.5 is just reversing what we did up here. It's the same thing as saying multiply by 3 and divide by 2. We get 54.05 times 1.5 equals 81.075 kW, and that is our final demand answer. And that's really all there is to 3-phase feeder calcs. They're really very simple, and they're all, like I said, they're all the same. You just take the first 2 steps, do your calcs normal, and then that final step, and you're done. That's it. And that also wraps it up for the range calcs and all these examples. So I really appreciate you sticking around and watching, guys, and please give me a like and subscribe if you would. That helps me out a lot. I have a lot of other examples and a lot of other calculations on my channel. Please check it out. I've got multifamily, single family, commercial, schools, offices, all those load calcs. I've got deep dives and I've got crash courses for 2020, and I'm making the 2023s as I go. So feel free to check it out. And I will see you on the next one.